This is your lesson on how to find the perimeter of partial circles. So yesterday, let's review. You did a little bit of learning how to find the circumference of a circle. Remember, circumference is just a fancy word for perimeter. A circle is a special shape. It's not a polygon because it has curved sides, so it gets its own special name for its perimeter called its circumference. Today, we're going to find the perimeter of partial circles. So we're going to use that perimeter formula from yesterday. So I'm going to write it up here. I'm going to write, remember, circumference equals pi times diameter. We're going to use that to talk about semicircles and quadrants. So what is a semicircle? A semicircle is a half of a circle. It's half of a circle. And what is a quadrant? A quadrant, think about what quad means. Quad, like quadruplets, that would mean 4. So a quadrant is 1/4 of a circle, or a quarter of a circle. All right, so I have to find the perimeter of a semicircle. So this one's kind of tricky. Okay, when we do this, we're going to start off by, I'm going to use a highlighter. You might actually want to get one out. So you can pause me and get one out if you would like. But when I use my circumference formula, remember, circumference equals pi times diameter. That would be if I went all the way around the circle, all the way around the outside of the circle. Okay, I'm going to use that formula, but I only want to find, that's only going to help me find that portion, or what we call the arc of the semicircle. So what I'm going to do is I'm going to say, well, this is a half of a circle. So I'm going to take my circumference formula, but at the end, I'm going to say divided by 2, since it's half of a circle. Another way you could write this, because it's half of a circle, is you could say half of your pi times your diameter, half pi d. But I usually stick with this one right here. Okay, so first thing I'm going to do is find out that curved piece, that arc. Okay, so circumference then would equal 3.14 times my diameter. Remember from yesterday, diameter is all the way across the circle, and that's been given to me. It's 18 divided by 2. All right, so let's put that in our calculators. We have 3.14 times 18 divided by 2. Okay, so I find out the circumference of just this arc. Okay, remember, we're finding the length of just this arc. It is 28 and 26 hundredths. So what I oftentimes do is I'll highlight it, say, okay, just this part is 28 and 26 hundredths. But to find the perimeter or distance around a semicircle, I have to go all the way around the semicircle. Right now, I've only gone from here to here. I need to get back to where I started. If I started here, I need to get back to where I started. So what do I pass in order to get back to what I started? I follow my diameter, that 18 centimeters. So then I have an additional step when I'm finding perimeter. I have my arc, which I know is 28 and 26 hundredths, plus my straight diameter to get back, which it was 18. So that'll give me my total answer, which to go around the semicircle, I went 46 and 26 hundredths centimeters. All right, let's try that thought again. So again, perimeter of a semicircle. So I'm starting here, and the first thing I'm going to do is I'm going to go follow my arc. Okay, so I'm going to do that highlighted portion. So to do that, again, I need to do my circumference formula, but it's a semicircle, half of a circle, so I'm going to divide it by 2. That'll give me just that highlighted portion. So I'm going to plug in my information. Circumference equals 3.14 times the diameter. So let's look at what they gave us. It's saying from here to here is 5. Well, that would be my radius. I need my diameter all the way across this circle. So if my radius is 5, remember, I double that to get my diameter. So my diameter would be 10. And then I'm going to divide it by 2 so that I'm only getting the arc because it's not a full circle, it's just a semicircle. So I'm going to say 3.14 times 10 divided by 2. And I get 15.7. So I know that arc piece is 15.7. Okay, but remember, that's not where I started from. So far, I've only followed the yellow path. Now I got to get all the way back to where I started. So to do that, I got to do the diameter of my circle, which was right here. We said the diameter was 10. So I'm going to say 15 and 7/10 plus 10. That's the diameter of my circle. Would give me 25.7 centimeters again. So on a quiz, which will take some time, it's not anywhere in the super near future, it's really tricky for students to do the perimeter of a semicircle. We always forget that we have to add that flat side back in. If you can remember that, you're going to do really well when it's time to take that quiz eventually. All right, let's try another one. So this one doesn't have a picture. Whenever something doesn't have a picture, I always draw a picture when it's geometry. It's so helpful for your eye to see where things are. So it says a length of wire is bent into a semicircular arc. So I have a piece of wire and it's been bent into a semicircular arc. The length of EF is 21 centimeters. So that's from here to here, it's telling us is 21 centimeters. Find the length. Excuse me. Okay, find the length of the wire. So remember, this part right here, this is a little trickier. This part right here, we can't see. Okay, it's just telling us the distance between the two edges of my wire. I just want to know the length of the wire right here. I'm just trying to find the arc this time. I don't have to add that flat side back in. So I would say C equals pi times diameter, semicircle, so I'm going to say divided by 2. All right, let's fill in what we know. We know that pi, it says to use 3.14, so 3.14 times the diameter. Oh, that was given to us. It's 21. Divided by 2, because it's not a full circle, it's just half of a circle. So we're going to divide it by 2. So I'm going to say 3.14 times 21 divided by 2. And I find out the length of that arc is 32 and 97 hundredths centimeters. I don't have to add the flat side because we're just trying to figure that arc that the wire was bent into. All right, great job, guys. Let's flip it over to the back and let's talk about quadrants now. So a quadrant is 1/4 of a circle. Okay, so if I had a full circle and I split it into fourths, it's one of the 4 pieces. That's what we're talking about when we talk about a quadrant. Okay, so perimeter of a quadrant, we're going to start out the formula of a circle, the circumference of a circle. We're going to say circumference equals pi times diameter. Now we're talking about 1/4 of a circle. So what do you think we're going to divide by this time? You're right, we're going to divide by 4 because it takes 4 quadrants to make one full circle. So I'm going to divide by 4. When I do that, it's going to give me this arc piece that I just highlighted. That's what this formula will give me. It gives me this arc. We call it an arc. Okay, if I want to go all the way around, remember though, I have to find the arc plus this flat edge. Plus in a quadrant, it's got another flat edge. So it's starting here and working your way all the way around the shape. So let's figure out this arc piece first so that we can figure out the perimeter. I'm going to say circumference equals 3.14. Remember, you can use 3.14 unless it tells you otherwise. Times diameter. Oh, this is the part that's so tricky. All right, so I'm going to draw a circle on here again. So here's my circle. Here's my quadrant. This 21 is referring to that right there. Okay? Is this the diameter of the circle? No, that would be the radius of my circle, and I need the diameter. So I'm going to say 21 plus 21. That means my diameter here is 42. That's another place where it can be super tricky. Remembering that this right here, this flat side of a quadrant, that's actually just the radius. That's not the diameter of the circle. It's not going all the way across. It's just halfway across. Right? And then I got to divide it by 4. So I have 3.14 times 42 divided by 4. I find out that this arc piece is worth 32 and 97 hundredths. So this right here is 32 and 97 hundredths. But I want to go all the way around my quadrant. Okay, so if my arc piece, so I go from here to here, my arc piece is 32 and 97 hundredths plus, then I have this flat edge right here. That's worth 21. And then I'm not back up to where I started yet. Now I got to add this flat piece right here, which is another 21. So I'm going to say 32 and 97 hundredths plus 21 plus 21. That gives me 74 and 97 hundredths centimeters. And that is my distance around a quadrant. Another way you could look at it is, again, kind of like the front side, it's the arc plus, well, isn't 21 plus 21 actually the diameter? So you could say the arc plus the diameter will give you the distance around the quadrant also, whichever way is easier for you. Some people, it's easier to say, okay, the arc is 32 and 97 hundredths, write it down. This edge is 21, write it down. This edge is 21, write it down and add them all together. For some people, they can quickly see that two of the flat edges on a quadrant is going to equal 1 diameter. All right, let's try another one. A perimeter of a quadrant. All right, first thing I want to do is figure out that arc portion. Okay, so I'm going to say circumference equals pi times diameter, but we're talking about a quadrant, and a quadrant is a fourth, so I'm going to divide by 4. So I'm going to say 3.14 times 8 divided by, oh, I made a boo-boo. That 8, remember, is that 8 the diameter? No, that 8 is the radius. Okay, see, I even made the mistake. So I don't want to use 8 here. Let's cross that out. Let's just cross it all out. Okay, I'm going to say 3.14 times, hey, I need my diameter. So I've been given my radius, but if this was a full terrible looking circle, this would be my diameter. All the way across that circle would be 16 divided by 4. All right, so let's try it. 3.14 times 16 divided by 4. I get 12 and 56 hundredths. And that refers, again, just to that yellow arc part. Now I need to add my two flat sides together. And my two flat sides are the exact same measure. So I would say 12 and 56 hundredths plus this flat side, which is 8, plus this flat side, which is also 8. Or I could have said 12 and 56 hundredths plus the diameter, which is 16. That would also work. Your arc plus your diameter. All right, so let's try it. 12 and 56 hundredths plus, I'm just going to say plus 16, gives me 28 and 56 centimeters. All right, another one. A circular ring has a radius of 5 inches. It is cut into 4 equal parts. Find the length of the quadrant. Find the length of the arc of the quadrant. Use 3.14 for pi. Okay, no pictures given, so I always say draw on a picture. So a circular ring, so here's my circular ring, has a radius, that's halfway, remember, of 5 inches. It is cut into 4 equal parts. All right, I'm going to cut my circle into 4 equal parts. Find the length of the arc of the quadrant. Okay, it's just asking for the arc. It's not asking for all the way around. It's just asking for the arc, the curved portion of one of the quadrants. So I'm going to say, all right, well, I know all the way around the curved part is pi times diameter, but I am only doing a quadrant, so I need to divide it by 4. So I have 3.14 times my diameter. Remember, this 5 only represents your radius. Your diameter would be all the way across. So times 10. And then because it's a quadrant, we're going to divide by 4. So let's try it. 3.14 times 10 divided by 4. I find out the length of the quadrant, which is all I need to do, is 7 85 and my label would be inches. 7 85 inches. That's what this is right here. Okay, again, it just says find the length of the arc, and again, the arc is the curved portion. So I've answered my question. Okay, one more. A quadrant is cut from a square. The side of the square is 10 centimeters. Find the distance around the quadrant. This one can be tricky. All right, so here's a square. And what do we know about the square? It says the side of the square is 10 centimeters. Okay, and remember, squares, all sides are the same length. It says a quadrant is cut from a square. So that means here's my quadrant that's cut from the square. It's like cutting this portion off. I'm going to make that part go away. I want to know the distance around, all the way around. It says around the quadrant. Okay, so let's find this arc portion first. I always start with the arc portion. So I'm going to say, all right, I'm going to use my circumference formula, pi times diameter, except because it's talking about a quadrant, and I know there's 4 quadrants in a whole circle, I'm going to divide by 4. I'm going to use 3.14, so 3.14 times the diameter. Okay, when I look at this 10, that 10 does not refer to the diameter. Remember, the diameter would be all the way across the circle through the center. Okay, so if I had a full circle, it would be all the way across through the center. I just have a radius. But I know if I do 10 times 2, which is 20, it's going to give me my diameter divided by 4. All right, so let's try it. 3.14 times 20 divided by 4. I get 15 7/10. So this arc right here is worth 15 7/10. Okay, but it doesn't just ask for the arc, it asks for all the way around it. So I'm going to say, all right, my arc plus this edge, which is 10, and this edge, which is 10. Or I could say my arc plus my diameter, which we said was 20. That means the distance all the way around this quadrant is 35 7/10 centimeters. All right, there's some practice for you to try. See how you do. Good luck.